Hello guys, welcome to day 6 of my weekly physics challenge. So today we are going to solve a very simple problem using a linear graph. A graph that represents the motion of an object in a linear direction. Now let's get this. This is the graph, right? And the question is, the diagram above shows a velocity time graph representing the motion of a car. Find the total distance covered during the acceleration and retardation of the motion. Now this is the diagram, and what we are asked to find is the total distance during acceleration and during retardation. That simply means we are not asked to find the total distance of the movement of the car. We are only asked to find the total distance during acceleration and during retardation. Retardation simply means deceleration, right? Now, from here, this is when the car was accelerating to this point, right? From here, this is when the car was decelerating. So that means I'm going to calculate the distance from when the car was accelerating plus the distance from when the car was decelerating, right? So let's go there. Very simple. Now say distance covered during acceleration. Distance covered during acceleration. Okay, let me use this as A and this is as B. You notice that the shape here is what? A triangle. This is also a triangle. So that means triangle A, I have my triangle A. What is the area of this shape? The area of a triangle is half base times height, right? Good. So let me bring out what I have there. I have half open bracket. My base is what? The distance from here to here, which is 10 times my height. You notice from here to here represent here. So my height is also 10, right? Good. So what I have is 1/2 times 10 times 10 is 100. So the area of this first triangle, when I divide this and this, I'm going to have 50 meter square. This is the area of the first triangle, right? The next thing is I'm going to calculate the distance covered during deceleration, that is during this side. Okay, now my height is still the same, 10, right? Now the base, now you notice that I have 40 here and I have 50 here. That simply means it is half of the space between this, which is what? From here to here should give me what? 5, right? So distance covered during deceleration during my retardation, distance covered during retardation is triangle B, right? So the area of triangle B is equal to the same thing, half base times height, right? Good. So what I have here, the base is what? Half of this, which is 5, times 10, which is my height, the same height, right? So what I have is 5 times 10 will give me 50. So area is going to be 25 meter square, right? So therefore, what I'm going to do is the total distance now covered during the acceleration and deceleration. Now total distance is going to be area of triangle A plus area of triangle B. Now my triangle A is 50 plus triangle B is 25, right? So what I'm going to have is 75 meters, right? Good. This is the total distance, right? So I have a question for you to solve for me. Just check, just check down. You will see that question. You will solve it for me, right? Thank you. Please do well to invite family and friends to join this educative challenge, right? Thank you. Bye.